Students, it's Mr. Hajgassim here, and today we're going to learn how to draw Venn diagrams and calculate probabilities from them. Now, before we start, there is a Venn diagram notation that you need to be familiar with. We will cover this in more detail in another lesson, but just as a recap, where it says shading the region that represents A and B, this means the intersection of A and B. So this symbol here that looks like an N, it means the intersection of A and B. So that's going to be this region here that I've shaded in blue. So this is A and B. And the region which is AUB, and this stands for the union of A and B, that's going to be A, so all of A, or all of B. So the union of A and B simply means A or B. A and B means the intersection of A and B, or A and B. So this is the region where we have A and B. All of A and all of B is A or B. So make sure you understand and know the difference between the two types of notation that we have. So this is intersection, this is union. All right, and moving on. So now what we have is a Venn diagram, and we need to be able to understand what our Venn diagram is telling us and all the notation that comes with Venn diagram problems. So this symbol here just means the universal set. So our universal set is numbers between 1 all the way to 10. And all of these numbers, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, they are elements of the universal set. So if you ever hear the word element in the context of a Venn diagram, don't be confused by it. It's just one of the numbers, or one of the objects that needs to go into our Venn diagram. Now set A, so set A, that's the red circle, that contains all of the odd numbers in our universal set. So that's going to be numbers 1, 3, 5, 7, and 9. And set B contains all of the prime numbers. So in the blue circle, we will write all of our prime numbers. So all of our prime numbers are going to be, so 1's not a prime number. Prime numbers only have 2 factors. 1 only has 1 factor, 1. Whereas 2 has 2 factors, 1 and 2. Both 1 goes into 1 and 2 goes into 1. So 2 is a prime number. 3 likewise only has 2 factors, only 1 and 3 go into 3. 5 is a prime number, 7 is a prime number, and these are all of our prime numbers here. Now, when we start filling in our Venn diagram, we always start in the intersection. So the elements that are common in both sets A and sets B. So set A is the red circle, set B is the blue circle. So what numbers do they both have in common? Well, they both have 3 in common. So I'm going to allocate 3 only once and cross them out. And I'm going to cross it out here so I know I've used it and I don't use it again. And then 5 is also common in both sets. Oh, sorry, I've done 7 there. And then 7 is also going to be allocated in the intersection because that's common in both sets as well. So I'm going to cross out 7. And then for the odd numbers in set A, I'm left with 1 and 9. And I'm going to cross out 1 and 9 here. And then for the prime numbers in set B, well, that's just going to be 2. So I'm going to cross out 2. And now the only numbers that are remaining are 4, 6, 8, and 10. So they go outside of A and B in our box. So we're going to have 4, 6, 8, and 10. 4, 6, 8, and 10. And now we can see I've crossed out all of my numbers. So that means I've used them in my Venn diagram. But I'm just going to check. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this is what my Venn diagram will look like. All right, so like I said, here are some definitions if you just want to have a quick read of them. So a set is a collection of numbers or objects. In this case, all odd numbers are set A, all prime numbers are set B. The objects that are in a set are called elements. So for instance, 2 is an element in a universal set. 2 is also an element in set B. And here it says 9 and 3 are elements in set A, which is true because they are both odd numbers. And the universal set is a set that contains all the elements in our Venn diagram. All right, let's move on then. So here the universal set is numbers 1 all the way to 20. And set A are all the square numbers, and set B are all the even numbers. So it says here, list all the elements in set A. So all the square numbers from 1 to 20, well, 1 times 1 is 1, so a square number is the product of a number multiplied by itself. So 1 times 1 is 1, so 1 is a square number. 2 times 2 is 4, 4 is a square number. 3 times 3 is 9, 9 is a square number. And then 16, and then up to 20, that's our last square number because 4 times 4 is 16, but 5 times 5 is 25. So these are all our square numbers, so they will be in set A. And then it says list the elements in set B. So the elements in set B, well, they are going to be all the even numbers between 1 to 20. So that's going to be 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20 itself. Now, so if I was to draw a Venn diagram here, and I'm going to draw one as a rough sketch, what would our Venn diagram look like here? So we can have set A, so all of the square numbers, and then set B, all of the even numbers. But first we have to start in the middle. So to start in the middle, what numbers do they both have in common? Well, they both have 4 in common, and they both have 16 in common. So I can cross these out, 4 and 16. And it might be best if I write out the rest of the numbers as well. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So 4 and 16 have been crossed out, and I will cross them out here as well from our universal set. Are there any other numbers in common? No, there ain't. So we have 1 and 9 in set A. So I will cross out 1 and 9. And then we have 2, 6, 8, 10, 2, 6, 8, and 10, 2, 6, 8, and 10. So 2, 6, 8, and 10. And then 12, 14, 18, and 20. 12, 14, 18, and 20. 12, 14, 18, and 20. So 12, 14, 18, and 20. And the benefit of crossing the numbers out as you allocate them into your Venn diagram, you can now clearly see which numbers are left. So we have 3, 5, 7, 11, 13, 15, and 17, and 19 for that matter, that still need to be allocated in our universal set. So those are the numbers that go outside of set A and set B in the box. So we have 3, we have 5, we have 7, we have 11, we have 13, 15, 17, and I can put 19 here as well. It doesn't really matter where in the box you put these numbers, so long as you put all of them. So we've done 3, 5, 7, 11, 13, 15, 17, and 19 as well. So this is what our Venn diagram will look like. All right, now moving on here, it says list all the common elements in the two sets. So the universal set is numbers 1 to 12. So that's going to include 3, 4, 5, 6, and so on. So we want all the factors of 12 in set A. So factors of 12 will be, well, 1, 2, 3, 4, 5 is not a factor, but 6 is. 7, 8, 9, 10, and 11 are not, but 12 is also a factor. And then the multiples of 3, well, the multiples of 3 are going to be 3, 6, 9, and 12. So a list of common elements. So the common elements are the numbers that are common in both set A and set B. So I'm not going to draw a full diagram. I'm just going to write out the common elements. So 3 is a common element, so that goes in the middle. 6 is a common element, and 12 is also a common element. So list of common elements, so that's just going to be 3, 6, and 12. And then you can fill out the rest of the Venn diagram. And then in the second example, so here what we have, it says the universal set are numbers 1, 4, 9, 16, and 25. So these are all of our square numbers up to 25. And then in set A, we have multiples of 4. So multiples of 4 are going to be 4 and 16 from this universal set. Now I know we have 8, 12 as well, but we just want the multiples of 4 from the universal set. So that's just going to be 4 and 16. And then set B is numbers 1, 9, and 16. So the only numbers that are common in both sets, so the common elements, are going to be 16. And 16 will go in the middle, and then you can fill out the rest of your Venn diagram. Now, here's a question. So it says the universal set are even numbers between 1 and 31. So it might be worthwhile just to draw these even numbers out. So that's going to be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and then we have 22, 24, 26, 28, and 30. Now, we've been given the numbers in set A, and we've also been given the numbers in set B. So what are the common elements? Well, they both have an 8 in common, so 8 goes in the middle. I'm going to cross them both out, and over here as well. And they also have 18 in common. So I'm going to allocate 18 and cross them both out. And then they also have 22 in common. So we can allocate 22 in the intersection and cross it out over here. The remaining numbers are 2, 4, 14, and 28. So 2, 4, 14, and 28. So 2, 4, 14, and 28. So we've got 2, 4, 14, and 28. That needs to be crossed out. And then we have 10, 16, and 30. 10, 16, and 30. That go in set B. So 10, 16, and 30. And the remaining numbers, so we have a 6 that's remaining. We have a 12 that's remaining. We have 20, 24, and 26. So 20, 24, and 26. So that's all of our numbers that have been allocated. Now it says find the probability of A and B. So earlier in the lesson, I showed you the region that is A and B. So the region that's the intersection of A and B is going to be this region here. So we have, if a number was chosen at random, the numbers that fall in this region are 8, 18, and 22. So that's 3 numbers. So for B, we have 3 numbers out of a possible, how many numbers do we have then? So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 3 out of 15, which simplifies to 1 over 5. So the probability of a number being chosen from this region, from the intersection of A and B, is 1 over 5, which is the same as 20% as well. And for C, it says find the probability that a number is from the region AUB. So that's A or B, or the union of A and B. So for the union of A and B, that's going to be all of A or all of B. Now again, we have 15 possible numbers that could be selected. However, the numbers that are in this region, the union of A and B, are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 out of 15, which is now going to be 2 over 3, which is 66.6 recurring percent. So very important to be familiar with the notation, because it's through these notations that probability questions can often be set. All right, and moving on. So here's our last example. So the Venn diagram's been drawn for us. It says an element is being chosen at random, work out the probability of AUB. So again, AUB, like the last question, is all of A and all of B. So the numbers that fall in AUB are 1, 2, 4, 8, 9, and 7. So that's a total of 1, 2, 3, 4, 5, 6 possible numbers out of 9. So that's going to be 6 over 9, which is 2/3. And then the probability of A dash, or the complement of A. Now, we didn't talk about this notation, but A dash, or also known as the complement of A, is everything that is not A. So the probability of A would be everything that's A, and this would be quite nice to mix up with probability. So if we were to work out the probability of A, well, that's going to be all the numbers that are here, 1, 2, 3, 4. So that's 4 out of 9. So the probability of not A has to be 5 out of 9, because the probability of all outcomes, so the outcome of A and the outcome of not A, has to add up to 1, and 4/9 plus 5/9 is equal to 1. So the probabilities match up nicely. If I wasn't to do it this way, and if I was to shade the region that is not A, that's going to be everything on the outside and everything in this B region as well. So how many numbers are in the shaded region? Well, that's 1, 2, 3, 4, and 5. So again, it's going to be 5 out of 9. So you could have worked out the probability of A, and from there did 1 minus 4/9, which gives us 5/9, or you could have simply shaded in the region that is not A and still got 5 numbers out of a possible 9. All right, well, boys and girls, that's it for today's lesson. So key takeaways here is how to draw your Venn diagrams, and also be familiar with the notation that are used in different questions. And in fact, before I wrap up, maybe we can do one more. So work out the probability of A and B. Well, hopefully you'd be able to recognize that this is the region here that we're looking for. So that's going to be one number out of a possible 9 numbers. So the probability of A and B is 1 over 9. Right, I hope that helped. Thank you very much and have a good day. Bye.